Emotion and affect are indeed closely related concepts and are often used interchangeably in everyday conversations. However, in psychology, they are treated as distinct concepts. Affect is often believed to be deeply connected to bodily sensations and responses. It frequently reflects changes in our internal bodily state, visceral activities and autonomic nervous system states. And these changes contribute to our emotional experiences. Emotion, on the other hand, refers to the subjective conscious experience and interpretation accompanying affective responses. From this perspective, emotion and affect are closely intertwined. Specific affective states, bodily states, can give rise to emotional experiences, and in turn, emotional experiences can influence our bodily states and behavior. This supports the idea that mind and body are interconnected. This relationship between emotion and affect is also related to the James Lange theory, which suggests that external stimuli first trigger physiological responses, corresponding to affect. And our perception of these bodily responses then leads to the experience of emotion. In this sense, emotion is fundamentally the interpretation or perception of bodily states. Let's first examine affect. Affect is considered the biological and bodily response to external stimuli. The external stimuli we encounter daily are relayed to the brain through our sensory organs. The hypothalamus plays a crucial role in regulating these responses. It acts as a central hub regulating essential physiological functions such as heart rate, blood pressure, body temperature, appetite, and sleep patterns. The brain processes this information and generates appropriate responses. The hypothalamus is also closely connected to the pituitary gland, which secretes hormones and stimulates hormone secretion from other parts of the body. The adrenal cortex. These hormones regulate stress responses, secretion of adrenaline and cortisol and other bodily responses, digestion and immune reactions. In this way, external stimuli cause bodily responses through sensory organs, the brain, especially the hypothalamus and pituitary gland, the autonomic nervous system, and the endocrine system. These interact in complex ways, resulting in either fight or flight responses to cope with emergencies or specific responses like relaxation and recovery. This is affect. In addition to external stimuli, internal stimuli, known as interoception, are also significant. Interoception refers to signals from our body's internal organs, such as the heartbeat, stomach fullness, lung breathing, and skin temperature. These internal signals influence our emotional experiences, running in parallel with external sensory information. Next is emotion. Emotion is believed to arise from the interaction between biological responses, affect and cognitive evaluations. This understanding suggests that emotions are not just direct responses to external or internal stimuli, but are also influenced by how these responses are interpreted, experienced, and thought about on a conscious mental level. When external or internal stimuli are input into the brain through sensory organs, the brain interprets them and triggers adaptive biological responses, meaning affect. These manifest as changes in the autonomic nervous system or the endocrine system, such as increased heart rate, sweating, and changes in respiratory rate. Subsequently, at the conscious level of the mind, these biological responses, affect, are experienced as emotion through cognitive evaluations. For example, a physiological sensation of heart racing may be associated with the emotion of excitement, or a sensation of heaviness in the chest may be associated with the emotion of sadness. Here, interpretation refers to the process by which the brain infers the state of the external world based on sensory inputs. The brain continuously attempts to understand the unknown external world, and to achieve this, it needs to generate the best possible inference of the external world based on sensory inputs. This is achieved by the brain generating predictive models and evaluating how well sensory inputs match those predictive models. Any discrepancies between predictions and actual sensory inputs, prediction errors, are called free energy, and the brain works to minimize this free energy. Regarding emotion generation, when the brain triggers an adaptive response, it is based not only on external stimuli, but also on predictions of what these stimuli mean to the individual. Autonomic responses can also be considered the brain's predictions of the best actions, based on its evaluation of the current situation. Additionally, changes in interoception are also inferred by the brain. For example, a feeling of fullness in the stomach may indicate having eaten a meal, and an increased heart rate may suggest tension or fear. It is believed that these predictions significantly influence emotional experiences. When the prediction error, the difference between predictions and actual sensory inputs, is small, Indicating accurate predictions, the brain confirms the predictive model and maintains or strengthens it. This demonstrates that the brain correctly understands the current external situation, and as a result, bodily responses proceed as expected, leading to positive emotions such as a sense of security or accomplishment. On the other hand, when the prediction error is large, indicating a significant discrepancy between predictions and actual sensory inputs, the brain recognizes this as an unexpected event and attempts to update the predictive model by assimilating new information. The bodily response at this time varies depending on the situation, but often includes emotions like surprise, vigilance, anxiety, or confusion. This is a result of the brain rapidly processing new information to bridge the gap between prediction and reality. This process is an attempt by the brain to minimize free energy, as the brain continuously tries to make the best possible match between reality and predictions, in order to understand and react to the external world most effectively. When a person encounters a new situation for the first time and is surprised, their heart rate may increase. However, when they experience the same situation for the second time, their heart rate may not increase as much as during the first encounter. This reaction is a result of the brain learning from experience and integrating new information with previous experiences to update predictive models. This phenomenon is called adaptation or habituation. In new situations, it is difficult for the brain to make predictions about the new environment, leading to larger prediction errors. This results in biological responses such as an increased heart rate. However, after repeated exposures, the brain learns about the situation. In other words, the brain forms a more accurate predictive model of the situation, allowing for a smaller prediction error and often resulting in less intense biological responses. Through this repetition, the brain adapts to the new environment, improves predictive accuracy,